In this video, I'm going to explain how to write simple ladder logic program using Siemens TIA Portal software. And also I'm going to explain how to simulate written program using the PLC SIM software. Okay, let's open the TIA Portal. Once you install the TIA Portal software on your desktop, you will have this kind of several shortcut keys on your desktop. If you want to open the TIA Portal software, you have to double click on the shortcut key with the name TIA Portal and the version number. So here I am using the TIA Portal version 20. Double click. It will take a few seconds to open the software. Okay, this is the opening window for the TIA Portal software. We are in Start tab. Start tab, open existing project sub tab. So under the Start tab, you can see the several sub tabs: the create a new project, migrate project, the welcome tour, the install software detail, the help view, and also the user interface language. We are in open existing project. That means the project that you have worked on before are listed in here. The recent project that you have worked are listed in here. If you want to open any of these projects, select the project and click open. Then the create new project. If you want to create the new project, you have to click in here, the create new project. Then you have to give the name for the project and also the save location, and also you can give any comment for the project. And also the migrate project. Migrate project mean if you want to convert the version of the project, you have to go through this migrate project. And also the welcome to is given, and also the install software details are shown in here. That means the TIA Portal install software details are shown in here. And also the help view, it will open in a separate web page. Here you can see the help view. Okay, then at last you can see the user interface language is shown. That means the selected language for the user interface is shown in here. Okay, here we want to create the new project, so I'm going to click the create new project. So you can give any custom name for the project. Just give first TIA program, first TIA program. So save location, you can give any save location from here. Then you can give any comments relative to these projects. So I'm not going to give any comments in here. So create project. Then it will direct it to this kind of a window. Here we are in start first step. So under the first step we have to configure devices. So what are the devices we are going to add to our project? We have to define. So first click the configure devices. In here you can see the show all devices. Under the show all devices, no devices shown in here because we have not yet added the devices. So I'm going to click add new devices. Then you can see the PLC controllers, HMI devices, the PC systems. So yeah, first of all I'm going to add the controllers. If you know the device name, you can directly type it in here and you can add. So but here I'm going to select it from this tree. So controllers, all the controls are shown in here. Then you can see the HMI devices and the PC systems. So first of all we are going to take the controller. Here I'm going to select the S7-1200 type PLC. Okay, let's take CPU module. Here I'm going to select yeah, 1215 DC type PLC. The version 4.7 I'm going to select. Here you can see the short description of the PLC shown in here. The work memory, the 200 kilobyte, the DC power supply with digital output, the 14 digital output 24 volt sync source type digital inputs, and also the digital outputs 10 digital outputs 24 volt, and also the 2 analog inputs, 2 analog outputs, and 6 high speed counters, the 4 false outputs. Then this kind of a short description is shown in here also, and also the article number is shown in here. If you are ordering this PLC, this is the number you have to use, article number. Okay, then we are going to add this PLC to our project. So click add. Okay, initially it asks to select the PLC security settings. Under the PLC security settings, these are the things you have to set. So then the first one, the protection of confidential PLC data. You can give the fast password protection for the configuration data. But in this situation, I'm not going to use any password protection for the configuration data. So I'm going to uncheck this one. With the next one, you can set security for the communication. Here also I'm not going to set any communication security. If so, it might reduce the communication performance, so I'm not going to set any uh, communication security. So I'm going to uncheck this one. So okay, then next one, the PLC access protection. You can give the access control. So that means you can allow this PLC system to access for authorized persons only. But here also I'm not going to use any access control for the PLC. So I'm going to disable the access control. Click OK. Okay, so anyone can access the PLC. So other options, nothing to select. Okay, that's all. Okay, basically that's all. Yeah, so click finish. Okay, here you can see the selected PLC, and here you can see the empty rack also shown in here. Okay, the select the PLC and the go to the properties. You can see the properties of the PLC is shown in here. Under the general, you can see the properties of the PLC, and also you can see under the input outputs, you can see all the physically available input outputs are listed in here. So you can see the two analog inputs, two analog outputs, and digital inputs and digital outputs are shown in here. Then we are in the device view. There are also two views called the topology view and the network view. The topology view displays the physical connection between the Ethernet devices, and the network view shows the logical subnet and communication connection between the devices. Okay, let's go to the device view. Here here in a right hand side, you can add any expansion modules. So for example, if you want to increase the number of inputs and also the number of outputs, you can add any expansion module. For example, yeah, here I'm going to add yeah, the expansion module with 8 digital outputs and 8 digital inputs, 24-volt DC. For example, select this one and drag it over here. It will add it to the PLC. You can see the input outputs belongs to the expansion module. You can see these addresses are belongs to the expansion modules. Then these are the addresses belongs to the PLC, and these are the addresses belongs to the expansion module we added. Okay, then next we are going to write a simple ladder logic program, and we are going to simulate it. So first of all, let's go to the program block, the main program block. Open the main program, double click. Okay, here you can see the main program block. So we are developing our ladder logic program in here, is the project area. So you can see the first network is shown in here. So then you can take these instructions to develop your ladder logic program. So they simply drag and drop here to add the instruction to the network. So in right hand side, you can see all the basic instructions are listed in here. Here you can see bit logic operations. All the bit logic operations are listed in here, and also the time operations and the count operations and the comparators, math functions, the move instructions, data move instructions, and also the conversion operations, and also the program controls, and also the logic operations, and also the shift rotate operations are listed in here. Here you can see few instructions are listed in here, that is from the favorite list. So that means the things you added to this favorite list, that will appear in here also. If you want to add, for example, I will show. If you want to add some instruction, let's take the math instruction. If we if you add this instruction to the favorite list, that will show in here. You can see the instruction also added to this favorite list, that also shown in the favorite in this window. So then you can easily take this instruction to develop your ladder logic program. Okay, then first we are going to write simple ladder logic program. Let's erase this one. Here we are going to develop simple latch circuit and going to simulate. Okay, let's take the normally open contact. If you want to add this instruction to the network, simply drag and drop in here, so it will add it to the network. So then this is the normally open contact, so I'm going to take the normal output coil also. You can see the output coil. Then to develop the latch circuit, you all know we need some optional path, so I'm going to take the optional path in here. Click here, it will develop the optional path, and also another normally open contact, and also we have to add the normally close contact in here. I'm going to add the normally close contact in here, and also we have to connect these two, this branch and this one. So click here, it will automatically connect. So then we are going to give the addresses for this normally open contact, normally close contact, and the output. So the output we are going to take from the physically available output of the PLC. So you can access the physically available output addresses from here. The click expand the PLC and go to the local modules, select the PLC. Here you can see all the input outputs are listed in here. Physically available input outputs are listed in here. I'm going to take this output from the Q0.0. So if you want to add this memory address to the output coil, select this one, drag it over here. This output address is assigned to the output coil. So then I'm going to rename this tag as, so motor whatever output, I'm going to rename as bulb change. So then these are the inputs, physical inputs I'm going to give using the I0.0 here. So I'm going to rename it as start change. Okay, so then this is the stop button, so normally close button. So the, yeah, right click, rename tag, stop change. So then this is the optional path. You all know the Q0.0 memory we have to assign. We can simply type the Q0.0. We can take it from the tag table. So to open the tag table, click here. It will open the available tag table. So from the tag table, I'm going to select output, so bulb, enter. Here this is our simple latch circuit. So let's compile the program first. So click here to compile. Okay, here we can see 0 errors and 0 warnings. So then next we are going to simulate the program and run. Okay, to simulate the program, we are going to start the PLC SIM software. Then click here to start the PLC SIM. Click OK. Click OK. It will open the PLC SIM software, and also the virtual connection is developed in between these two softwares. Okay, for a while, the minimize this one. So the connect, click connect, it connect these two softwares. Okay, then we are going to load the program. We are going to load the configured data. Click load. So then we are going to start the module. Start module, the finish. Okay, so then we are going to monitor input outputs. The click here to monitor input outputs, monitor on off. Here you can see at initially, this is the here the blue color area is shown the no power area. Then this is shown the high power area. So then there's no power flow to the bulb because these are normally open contacts that has not switched. So there's no power flow to the bulb. Okay, so then we are going to simulate this one. Okay, we are going to switch these inputs using the PLC sim table. Okay, let's go to the PLC sim. Then click here. We are going to create the sim table, simulation table. So click add for the sim table. Here you can see the empty sim table has created. So for this sim table, we are going to import, assign input, outputs, and memory bits. So click here. Then sim table properties. So we are going to load the inputs, outputs, and memory addresses to the sim table. The load selected tags. Click here. Here you can see now the sim table has loaded with the tag, available tags. So start, stop, and the bulb. Okay, let's run the simulation. Okay, okay, so let me float this one. Okay, this is our sim table. Okay, then first of all we are going to change the state of the start signal. So here, so we are going to by put in the click in here, you can change the state of the input signal. So what happen if we change the input signal to the true, it develop the power flow to the bulb, you can see. And also its optional path also energize, so optional path also develop the power flow to the bulb. So if we change the state of the input signal to 0, you can see there's no power flow here, but there's an optional path has already created, so it retain the power flow, retain to the bulb. So if we want to stop the power flow, we have to press the stop button. So we are going to change the state of the stop button. Let's see what happens. If we change the state, then here you can see the power flow disconnected. Power flow disconnected. Okay, let me show it again. If we click the start button, you can see the power flow developed to the bulb. And also if we change the state of the I0.1 the stop button, you can see the power flow disconnected. This is how the latch circuits work. This is how latch circuits work. Here you can see another condition. Here it is a stop dominant. So stop dominant mean the priority is given to the stop button. If the stop button is pressed, there's no power flow to the bulb. Okay, this is how we are writing simple ladder logic program in TIA Portal software, and this is how we are simulate this written ladder logic program in using the PLC SIM software. I think you will got clear idea. Okay, see you on next TIA Portal video. Thank you.